Alright, so this is paper 1 of mock 3. Substance X dissolves in water to form a colorless solution. This solution reacts with aqueous lead-2 nitrate in the presence of dilute nitric acid to give a yellow precipitate. So let's analyze the information one by one. And they're asking us to find out what is substance X. So it dissolves in water to form a colorless solution. That means that this can't be a transition metal, because we know transition metals form colored compounds. So not transition metal. So if you look at our options, iron and copper can't be the answer because those are transition metals. Now let's look at the second part. The solution reacts with aqueous lead-2 nitrate in the presence of dilute nitric acid to give a yellow precipitate. This yellow precipitate is lead iodide. The second sentence is essentially just the test for iodide ions. So lead iodide was formed. That means our substance X must contain iodide ions as well. In that case, it can't be D either because that's sodium chloride. So the answer for A should be calcium iodide. Moving on to number 2. The diagram shows a diffusion experiment. We have a beaker, a porous pot, some oxygen inside a container, a pipe filled with water, and open on one end over here. Which gas, when present in the beaker over the porous pot, will cause the water level at Y to rise? So first we need to understand why the water level, or how it can rise in the first place. So keep in mind that since it's open to the atmosphere on this end, the atmospheric pressure is pushing the water down. And the oxygen inside over here is pushing the water from the left side. And as a result, they're in this equal height at the moment. But if there is a scenario where the pressure due to the gas from this container increases, in that case the water will be pushed and pushed higher in Y, because the pressure due to the gas over in this container is now greater than the atmospheric pressure. So as a result, what we basically need is a gas that's going to diffuse inside this container, while also keeping in mind that this is a porous pot. Now, the feature of a porous pot is not only does it allow the oxygen to diffuse out, it also lets any gas in the beaker to diffuse in. So we need to think of two factors. Factor 1, it's going to diffuse. Factor 2, it's going to diffuse faster. Faster than whom? Faster than oxygen. Because think about it, if the oxygen diffuses faster than the incoming gas, won't the overall gas pressure decrease? So to avoid the decrease in gas pressure, we need a gas that's going to diffuse faster than oxygen. So now, to diffuse faster than oxygen, first of all, the factors affecting diffusion would be temperature and MR, or mass. Now, the temperature is going to be the same for all the gases over here, even for oxygen. So that isn't a factor. The main factor over here is going to be mass. So now if we compare all the masses of the gases over here, it's very obvious that CO2 will have a mass that's greater than oxygen. Cl2 will also have a mass greater than oxygen. NO2 will also have a mass greater than oxygen. And only CH4, methane, is the gas that has a mass less than oxygen. So since it has a lower mass than oxygen, this will diffuse in faster. As a result, the answer for this question is going to be C, methane. Because as the methane gas diffuses in faster, the gas pressure increases and the atmospheric pressure is constant. So it's not like it's going to increase by any chance. So that stays constant. So since there is an increase in gas pressure on the left hand side, the water level on Y will rise. Moving on to the next question. Over here we have a diagram which shows the apparatus used to obtain carbon monoxide. So just an explanation of the diagram, we are adding dilute hydrochloric acid. We have a sample of calcium carbonate in this round bottom flask. We also have a tube which is filled with lumps of charcoal and it's being heated. And then there is a conical flask with a substance Y, a solution Y. And then there is a delivery tube, and we are collecting carbon monoxide by displacement over water. So that is the setup. Now, the reactions involved over here are, so dilute hydrochloric and calcium carbonate are reacting. So HCl plus calcium carbonate, so CaCO3. And the products for this reaction should be CaCl2 plus CO2 plus H2O. And to balance it out, even though the balancing isn't important for this question, we just had a 2 over here. So this is the first equation. And look at the products over here. We get calcium chloride, we get CO2, and we get H2O. So CO2 is the gas, and let's say steam was also produced by some chance. It doesn't affect anything in this question. So the CO2, the gas, will travel up this tube, and then it will pass through the lumps of charcoal. And as it passes through the lumps of charcoal, another reaction takes place, and this is the one that's going to produce carbon monoxide. Charcoal is just carbon. So carbon plus carbon dioxide is going to give you carbon monoxide. So we have the gas that we desire. Now this carbon monoxide will pass through this tube and through solution Y, and then through this tube and collected over water. So we need to understand what's the purpose of Y over here. Now, before we actually think of what could be Y, let's think of a logical way to deduce the answer. Now, look at this. Carbon monoxide is passing through water at the end of the reaction. So if we look at option 1, to dry the gas, if we are drying the gas and then passing through the gas over water, isn't it becoming wet again? So is there any point of drying the gas if it's just going to pass through water or pass over water at the end of the reaction? So logically, A doesn't make any sense. Now let's look at B, to prevent water being sucked back onto the hot carbon. Now again, if we were to think over here, there is no carbon involved. All the carbon is present as lumps of charcoal. So again, B doesn't make any sense. Now let's look at C, to remove carbon dioxide from the gas. Now this one might make sense, because let's say there is no guarantee that all the carbon dioxide over here will react with carbon to give you carbon monoxide, because it's not like the carbon dioxide just stops over here. It keeps on passing. So as it keeps on passing, some of the carbon dioxide indeed also moves along with carbon monoxide. So in this tube, or in the conical flask, we have both carbon monoxide and carbon dioxide. But what is our goal at the end of the reaction? To only collect carbon monoxide. So we need to get rid of carbon dioxide somehow. So C, being to remove carbon dioxide from the gas, does make sense. But let's look at D, to remove hydrogen chloride from the gas. Hydrogen chloride was a reactant used, and it wasn't a product, or it wasn't a gaseous product. So in that case, there is no chance of hydrogen chloride just passing up into the lumps of charcoal and then towards the conical flask. So D doesn't work as well. So the most plausible and the most logical answer for this question is going to be C. Moving on to the next question. The boiling points of various gases found in air are shown. So we have argon, carbon dioxide, nitrogen, and oxygen. If the air is cooled, the first substance to condense is water. So water has a boiling point of 100 degrees Celsius. So it's obvious that it's going to condense before all of the other gases. And the next gas to condense should be the one with the highest boiling point. So in that case, if you were to look at our options, we have argon, carbon dioxide, nitrogen, and oxygen. Carbon dioxide has a boiling point of minus 78. And this is the second highest boiling point if we consider water as well. So in that case, carbon dioxide should be the one to condense after water. All right. This is another question about experimental setup. The fractional distillation apparatus shown is to be used for separating a mixture of two colorless liquids. A thermometer is missing from the apparatus. Where should the bulb of the thermometer be placed? So this is fractional distillation. And in fractional distillation, we try to separate two miscible liquids, and the separation is done based on boiling points. So since the separation is based on boiling points, it's very important that we know what the temperature is of our setup and what is the temperature of the gas that's passing into the condenser. Because if it's a scenario where both of the liquids have converted to gases and both of them are passing into the condenser at the same time, we won't be able to separate them. So it's very important we know the temperature of our gases. As a result, the pathway of the gas is basically up this fractionating column through this point into the condenser. So the ideal position of the thermometer bulb is at B. So your thermometer, if you were to place it, would be something like this. So at B, you'd have your thermometer bulb, because at this point it passes just into the condenser. C would be too low, because let's say if some of the gas of the other liquid did evaporate, it might reach C and then you'd again get a false reading for the temperature. So that is why B is the point that's most ideal, and D doesn't make any sense. Why would you measure the temperature of the liquid afterwards? All right, number 6. Hydrogen can form both H plus ions and H minus ions. Which one of the statements below is correct? So let's look at our options. An H plus ion has more protons than an H minus ion. Regardless of what kind of ion we form, a positive ion or a negative ion, the number of proton for a substance, for the same element, will never change. So A doesn't work. An H plus ion has no electrons. So if you were to recall, hydrogen only has one electron. So to form an H plus ion, the hydrogen essentially loses that electron. So since that electron is lost, H plus is formed. So we can basically say H plus has no electrons. So for 6, the answer should be B. Number 7, a dark shiny solid conducts electricity. Oxygen combines with X to form a gaseous oxide. What is X? So let's look at our options. It conducts electricity, so it must be something that has delocalized or free electrons. So it can't be iodine, because iodine doesn't conduct electricity. Now it's between graphite, iron, and lead. Look at the second part. Oxygen combines with X to form a gaseous oxide. Think of graphite. Graphite is just carbon. So carbon and oxygen do react to form carbon dioxide, and it's the only gaseous oxide, because iron and lead, both of them form solid oxides. So for 7, the answer is A. Moving on to number 8, the diagram shows the molecule ethyl propanoate. How many bonding pairs of electrons are there in the molecule? For these types of questions, always draw the displayed formula first. So that is what we are going to do over here. So we draw the displayed formula by just showing the hydrogen bonds present. So O and a CH like this, and finally the last 3 hydrogen. So they ask for the bonding pairs of electrons. Each bond is a bonding pair. So each bond is a bonding pair. So all you really have to do is just count the number of bonds over here. So if you were to do that, we have 1, 2, 3, 4, 5, 6, 7, 8, and 9. A double bond counts as 2. So 10, 11, 12, 13, 14, 15, 16, and 17. So we have 17 bonding pairs. So the answer should be C. Moving on to number 9, the conduction of electricity by metals is carried out by the movement of, it's always going to be electrons, because this is just metals. Which substance could be sodium chloride? So this is what they're asking for number 10. So sodium chloride is an ionic compound, and as we know, ionic compounds, they conduct electricity when liquid. So when liquid, the conductivity must be good, and it must conduct electricity when in an aqueous solution. However, if you look at your options, if you just look at the liquid column, we have nil for all the 3, for A, B, and D, and we only have a good conductor for C. So we don't even have to look at the other columns to determine our answer. So for 10, the answer is simply C. Question number 11. Cracking of hydrocarbons breaks them into smaller molecules. Which example of cracking would produce the largest volume of products from 1 mole of hydrocarbon. Assume that all measurements are made at the same temperature and pressure. For this question, the most important concept is for these chemical equations, when they're balanced, the ratio of moles is equals to the ratio of volumes. And using this concept, we'll simplify this question a lot. So basically, in whichever chemical equation we get the highest number of moles of products, we will also get the highest number of moles of, the highest volume of products. So if we look, why this works is because moles is equals to volume by 24 or 24,000, however you take it, depending on cm cube or dm cube. So volume and moles are essentially just moles is equals to K times volume. So moles is directly proportional to volume. That is why this ratio works over here. So we have 1 mole of each. So let's check. So when we have 1 mole of C6H14, we get 3 molecules of C2H4 and 1 molecule of H2. So that's 3 plus 1. We get 4 molecules. For B, it's 2 plus 1, so that's 3. For C, it's 1 plus 1, so that's 2. For D, it's 1 plus 2, so that's 3. So A has the highest moles of gas, and if it has the highest moles of gas, it will also have the highest volume of gas. So for 11, the answer is A. Moving on to number 12, when 20 cm cube of gaseous alkene burns in an excess of oxygen, 60 cm cube of carbon dioxide are formed. Both volumes are in RTP. What is the formula of the alkene? So immediately, if you look at B and D, they can't be the answer because both of them are alkanes. Because alkanes have the formula CnH2n plus 2, and both of them follow that. In A and C, we have alkenes, so we will elaborate further on those. So first of all, the general combustion equation for hydrocarbons is something like this: CxHy, or since these are alkenes, let's write CnH2n plus O2, CO2 plus H2O. So since we have 2, this is going to be an N over here, and over here there might be something that's being multiplied with that moles of alkene, so we don't know that. But now look at the volumes. The alkene's volume is 20 cm cube, carbon dioxide's volume is 60. So just a while back we learned that the volume ratio and the mole ratio, so the ratio of volumes is equals to the ratio of moles in the balanced equation. So what's the ratio of volumes over here? It's 20:60, and if we simplify this, we get 2:6, and if we simplify it further, we would get 1:3. So what we can basically conclude over here is, if we were to balance this, we would have a 1 over here and we would have a 3 over here. So in that case, if we look at our options, the only alkene with 3 carbons over here would be A. Now if it was C6H12, then we would have 6 carbon over here. But according to the balance ratios, we just deduced that there's going to be 3 carbon. So for 12, the answer is A. Moving on to number 13. Metafuel C8H16O4 is a fuel used in camping stoves. What is the equation for its complete combustion? So metafuel, this is not a conventional compound that we learn about, but complete combustion is something that we know. In complete combustion, we will always get CO2 and H2O. So if you get CO2 and H2O in complete combustion, A and B are wrong because these are incomplete. We got carbon and carbon monoxide. And similarly, if you look at D, we do get carbon dioxide, but we also get a bit of carbon monoxide. So this is also incomplete combustion. So in that case, just using the idea of complete combustion, we eliminate all the answers, and our answer for 13 is C, the only one with complete combustion. So despite not balancing the equation or even checking its balancing, C is the answer. Moving on to question 14. Dilute sulfuric acid is electrolyzed using inert electrodes. Which equation represents the reaction at the anode, the positive electrode? So for sulfuric acid, the ions present would be H plus, SO4 2 minus, and OH minus. So at the anode, we will get the anions, and between sulfate and hydroxide ions are always going to be discharged. So if you look at our options, C has the discharge equation for hydroxide ions. So the answer for 14 is going to be C. Number 15. What are the products when concentrated aqueous lithium chloride is electrolyzed? So when it's concentrated, let's just write down the formula. So lithium chloride, the ions present, the cations will be Li plus and H plus. The anions will be OH minus and Cl minus. The H plus and OH minus is because it's aqueous. So now it's concentrated, and whenever a solution is concentrated, if it contains halides, it's the halides that will be discharged. So in this case, chloride will be discharged, and the anions are discharged at the anode. So it's going to be chlorine at the anode, and at the cathode, it's between lithium and H plus. Since H plus is less reactive than lithium, it's going to be hydrogen. So the answer for 15 is going to be A. Number 16. A solid deposit of element R is formed at the cathode when an aqueous solution containing ions of R is electrolyzed. Which statement about element R must be correct? So R is formed at the cathode, so R must have formed a cation. Now let's look at our option. R forms negative ions. Cations are always positive, so this can't be the answer. R gains electrons at the cathode. That is what happens at the cathode. So the answer must be B. Let's look at the other ones. Are ions lose electrons at the cathode? No, that is not what happens. R is above hydrogen in the reactivity series. If R was above hydrogen in the reactivity series, then R wouldn't have been discharged because it is an aqueous solution. So we also have H plus present. So all the metals that are above hydrogen in the reactivity series, they will not be discharged. It will be hydrogen that's discharged. So it can't be that R is above hydrogen in the reactivity series. Number 17, apparatus was set up as shown. So we have an electrolysis setup. We have metal X, metal Y, and there is an arrow indicating flow of electrons. For which pair of metals would electrons flow in the direction shown? So for this type of setup, the electrons will always flow from the more reactive metal to less reactive metal. Because think about it, metals, when they react, what do? They lose their electrons. So let's say if the metal is M, it will lose electrons to, let's say, form M2 plus and the 2 electrons. So the 2 electrons that were released, where will they go? They will go to the other end where we have our less reactive metal. So in that case, X is going to be more reactive and Y is going to be less reactive. So in that case, our option should be arranged in that way. So look at A, copper and zinc. That doesn't work because copper is less reactive. Iron, aluminum, iron, magnesium, both of them don't work because iron is less reactive. If you look at D, zinc and silver, that is correct. Zinc is more reactive than silver. So in this case, it's going to be D. Moving on to number 18, the table shows the energy released by the complete combustion of some compounds used as fuel. So we have the name of the compound, the formula, the MR, and the enthalpy change per mole. Which fuel produces most energy when 1 gram of the compound is completely burned? So for this question, all we really have to use is energy is equals to moles times enthalpy change. And since we have the mass and the MRs, mole is going to be simply mass by MR. And then we multiply del H. So all we really have to do is just find the energy for all 4 of the cases. So for the first one, if we do that, it's going to be 1 by 16 times 880. For the second one, 1 by 46 times 1380. 1 by 44 times 2200, and lastly 1 by 100 times 4800. So now we just have to calculate the value for all of them, and if we just quickly check that, so for the first one it should be 55, for the second one it's 30, then 50, and lastly 48. So which one releases the most energy? It's methane. So if you look at our options, it should be C. Moving on to number 19, which reaction is the fastest? So we have an experimental setup over here, a reaction between hydrochloric acid and lumps of carbon, and we also have the water at two different temperatures. So for the fastest reaction, the temperature must be greater. So between 30 and 60, our goal is to get 60, because at higher temperatures the rate of reaction is higher. And then the concentration of hydrochloric acid should be concentrated instead of dilute. So concentrated over dilute. And the calcium carbonate should be in its powdered form instead of the lump form. So 60 degrees Celsius, concentrated and powdered. So we look at the option that provides all three of them. So if you look at A, that doesn't work. B, C, that doesn't work. If you look at D, water at 60 degrees Celsius, hydrochloric acid concentrated, powdered calcium carbonate. So the answer for 19 is D. Moving on to question number 20, the diagram shows the reaction pathway for a reaction without a catalyst. Which diagram shows the pathway resulting from the addition of a catalyst to the reaction? So when we add a catalyst to the reaction, the only change that is made is the activation energy is reduced. So activation energy is reduced, and this is due to an alternative mechanism. So if you look at our options, A has an increased activation energy, that doesn't work. B has also changed the enthalpy change, so that doesn't work. C has a lower activation energy, so C works. And D is again changed the enthalpy change, so D doesn't work. Moving on to question number 21. A colorless gas is passed into each of three different solutions. The results for each solution are shown in the table. So we have list of solution: potassium iodide, acidified potassium dichromate, acidified potassium manganate, and we have the results as well. Now if you look at the solutions, potassium iodide is a reducing agent and the other two are oxidizing agents. So we can have an idea that this question is probably referring to redox reactions and oxidizing and reducing agents. So let's look at the results. So for a reaction with potassium iodide, it stays colorless. That means there's no reaction. Because if there was a reaction, then the solution would have turned brown due to the aqueous iodine. And for the other two, there is a reaction. Now, the concept over here, or what they're asking, is what is the colorless gas? So the colorless gas, since it's reacting with oxidizing agents, it means that it must be a reducing agent. Oxidizing agent reacts with reducing agents. Because if you look at acid and alkali, we don't have information regarding an acid reaction or an alkaline reaction. What we do have is idea of whether it's an oxidizing agent or a reducing agent. And since it doesn't react with a reducing agent, it's not going to be a reducing, it's going to be a reducing agent. So it doesn't react with reducing agent potassium iodide, but it reacts with our oxidizing agent. And with oxidizing agent, only reducing agents can react. So the answer for 21 is going to be D. Moving on to number 22. Which observation is typical of a solid non-metal element? So it's a solid non-metal element. It reacts vigorously with chlorine. This is typical for metals. So A doesn't work. It conducts electricity. Again, generally metals. It's not a typical property. C, it has more than one oxidation state. Again, this is referring to transition elements or transition metals, so that doesn't work. It forms an acidic oxide. Non-metals generally do form acidic oxides, so the answer for this is D. Which reaction represents the reaction between hydrochloric acid and sodium hydroxide? So this would be a neutralization reaction, an acid and a base, or an alkali. And if you look at our options, all of them are ionic equation. So we also need to write the ionic equation over here. So if we try to do that, so H plus Cl minus plus Na plus OH minus forms H2O plus Na plus Cl minus. So H2O is in liquid form, the ions are in their aqueous forms. So if you write AQ quickly, and the concept is, if an ion is present on both sides, it's called a spectator ion. And the goal is, for ionic equations, we remove the spectator ion. So in this case, if we do the same thing, chloride ions are present on both sides, so that's a spectator ion. Na plus ions are present on both sides, so that is also a spectator ion. So our finalized equation, if we look, is simply H plus OH minus forming H2O. And this is the ionic equation for any neutralization reaction. So that is why the answer for this one is going to be D. Moving on to number 24, the following statements about dilute sulfuric acid are all correct. So we don't have to worry about whether it's wrong or not, but if we check, which two statements confirm the acidic nature of the solution? So we need to find the statements which refer to the acidic property of sulfuric acid. So if you look at 1, a white precipitate is formed when aqueous barium chloride is added. So this doesn't indicate anything about an acid-base reaction or any acidic behavior. Then number 2, the solution turns anhydrous copper to sulfate from white to blue. Again, this doesn't refer to any acidic property. At number 3, addition of universal indicator shows that the solution has a pH value of less than 7. All acids have a pH of less than 7. So 3 shows an acidic property. And then number 4, the solution reacts with copper to oxide, forming a blue solution. Copper to oxide is a base. So this is showing that it's reacting as an acid, because bases react with acids. So in that case, 4 is also showing an acidic property. So for 24, the answer should be D. Moving on to 25, ammonia gas is produced when solid ammonium chloride is heated with. So ammonium chloride is a salt of ammonium, and ammonium salts react with bases. And when they react with bases, they form a salt plus ammonia plus water. So since ammonia gas was produced, we would look for the base over here, and A, calcium hydroxide, is the base. So that is why for 25, the answer is going to be A. 26, sulfur and selenium are in the same group of the periodic table. From this, we would expect selenium to form compounds having the formula. So for sulfur and selenium, both of them are in group 6 of the periodic table. So sulfur forms sulfide ion, which is S2 minus. So it's expected that selenium should also form something like an Se2 minus ion. And if that is the case, let's look at our option. If we form Se2 minus, then it can't be NaSe, because then the charges aren't cancelled out properly. So D doesn't work. And we also know that sulfur forms SO2 or SO3. So if you look, A shows SeO, sulfur doesn't form SO, so that doesn't work. So it's between B and C now. And look at the very last one, NaSeO4. We know that sulfate ion has a charge of 2 minus, so it's expected that Se4 should also be of 2 minus charge. And in that case, again, the charges aren't cancelled over here. So the answer should be C, which contains Ne2SeO4. Moving on to question number 27, X and Y are diatomic elements. X is less reactive than Y. What are elements X and Y? So we have chlorine, iodine, fluorine, nitrogen, iodine, bromine, and oxygen, nitrogen. Now let's try to recall a concept. Down group 7, reactivity decreases. And the reason for that was because the atom kept on getting bigger. So it got more and more difficult for the atom to gain an additional electron. And since the atom can't gain an electron, its reactivity has decreased. So if that is the case, if you look at C, iodine and bromine, iodine is below bromine in group 7. So in that case, C should be our answer over here. For the other ones, there is no immediate comparison that we can make. For chlorine, iodine, chlorine is above iodine, so chlorine should be more reactive. So that doesn't work. So that is why the answer over here is simply C. Moving on to number 28, a metal X in group 1 of the periodic table would be expected to. So it's group 1, so X should form an X plus charge. So form a nitrate of formula XNO3 2. That doesn't work because nitrate has a charge of minus, so the formula would simply be XNO3. Form an acidic oxide. Group 1 is a metal, and metals generally form basic oxides. So AB doesn't make sense. Form an insoluble chloride. All group 1 chlorides are soluble, so C doesn't work. If you look at D, produce hydrogen from cold water. D makes sense because group 1 metals are very reactive, so they do react with cold water. So group 1, very reactive. Moving on to 29, 4 test tubes were set up as shown. Each piece of iron was protected on one side by a different coating. In which test tube is iron least likely to rust? Now, since it's least likely to rust, we need to think of the test tube that has the most protection for iron, and it will protect it in two ways. First one, it covers the iron. Secondly, it will react in place of iron. Reacts in place of iron. So let's look at A. We have grease over here on top of iron, and it's underwater. So the thing is, if the grease all falls down, or if the grease gets removed from any one portion, then the entire iron would react. And the same logic applies for B and C. At any point, if the grease, paint, or plastic is removed, then the entirety of the iron becomes exposed and it will react. But at D, it's covered with zinc. So not only is it covered, zinc, which is more reactive than iron, is the one that's going to react even if the iron is exposed to water. So that gives an added layer of protection. So that is why D is the least likely to react or rust. Now, number 30, compound P is an alcohol with the molecular formula C4H10O. How many structural isomers are there of compound P? So let's draw the most simplest one. So 4 carbons, and it's an alcohol, so OH at the end, and these will be hydrogens. Now we want to form isomers, and it's only structural isomers. So the first thing that we could do is change the position of the OH. So let's draw that one. So it's going to be the same structure, the only difference being instead of the OH at the end, it's going to be an H now, and we add it over here. So this is another structure. So we have 1 and 2. And keep in mind, even if you add the OH to, let's say, over here, it's just the same molecule, but a mirror image of it or a flipped version of it. So it doesn't matter whether you give it over here or over here, it's the same molecule. So all of those would be your two options. And then another one that we can think of is if we create a branched alcohol. So we replace a carbon like this. Let's just quickly write CH3. So CH3, CH, H, and OH. So this could be another option. So this is 3. And over here, we can apply the same concept that instead of at the very end of the chain, maybe we add the OH in the middle. So if that is the case, another one that could be an option is something like this, CH3, 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 and the hydrogen is now an OH. And other than these four options, we don't have any isomers. So for 30, the answer is C. Moving on to number 31, three types of steel have different properties. So steel 1 is easily shaped, steel 2 is brittle, steel 3 is resistant to corrosion. And they're asking us the names of the three types of steel. So easily shaped means it's definitely mild, and a steel is brittle when it has high carbon. Metals by themselves are supposed to be malleable and ductile. So if a metal or if an alloy of the metal is brittle, it's due to the other substance present, which is why it's brittle. So in this case, it's because of the carbon, the steel is brittle. So steel 2 must be high carbon, and resistant to corrosion is most definitely stainless steel. So if that is the case, if you look at our options, C has steel 1 as mild, steel 2 as high carbon, and steel 3 as stainless. So 31 is C. 32. Which strategy reduces methane emissions? Methane is emitted from cows. So cows are a source of methane. And then biomass and all of that are also sources of methane. So if we can reduce biomass, then we will be able to reduce methane. And the source of biomass is livestock. Basically, cows is livestock. So if we can reduce livestock, then we can reduce methane. So if you look at our options, C is reduction in livestock farming. So the answer should be C. Use of catalytic converters, planting more trees, and flue gas desulfurization are all preventive measures for other gases. So those don't work over here. Number 33. A sample of white powder X is dissolved in water. Tests are done on separate portions of this solution, and the observations are shown in the table. So this is basically a test for ions question. So test 1, add aqueous sodium hydroxide a drop at a time until in excess. So a white precipitate forms soluble in excess, giving a colorless solution. So that means, since it's a test for cations, it could be Al3 plus or Zn plus. And then acidify with dilute nitric acid, then add aqueous silver nitrate, a white precipitate forms. This is basically the test for halide ions, and since this is a white precipitate, it must be Cl minus. And the last one, acidify with dilute nitric acid, then add aqueous barium nitrate. The solution remains colorless. This was basically the test for sulfate ions. Since if a white precipitate was produced, that would mean that BaSO4 was present, BaSO4 was formed and sulfate ion was there, but nothing like that was formed. So the ions present should be Al3 plus, Zn plus, or Cl minus. So if you look at our options, what is X? Aluminum chloride. So it contains the required Al3 plus and the Cl minus. So the answer for 33 is A. Moving on to number 34. Alkanes undergo a substitution reaction with chlorine. Which row shows two correct statements about the reaction between alkanes and chlorine? So in substitution reaction, what happens is one of the hydrogens of your alkane, so let's say if you have methane and chlorine gas, one of the hydrogens is going to be replaced. So one hydrogen will be replaced with a chlorine. So the products at the end of the reaction would be like this. So a chlorine is added and then HCl is formed. So in that case, statement 1, a carbon atom is replaced by a chlorine atom. That doesn't work, so those are out. So it's between B and D. And in statement 2, the reaction requires thermal energy. That is not correct. This reaction of substitution requires ultraviolet light. So the answer for this one is going to be D. Moving on to number 35, molecule of the compound C4H6 is shown. So we have the structure given to us. This molecule undergoes two separate addition reactions because there are two double bonds over here. It undergoes an addition reaction with excess bromine and an addition reaction with steam, which are normal reactions for any alkene. One molecule of C4H6 reacts with dash of bromine. When C4H6 reacts with steam, dash is formed. Which words complete gaps 1 and 2? So look, normally if we had ethene, in the one double bond that we have, one bromine molecule would have reacted and it would form something like this. So CH, Br, H, and H, and Br. So over here, since we have two double bonds, we will now need two bromine molecules. So we will need two molecules, and the reaction for an alkene and steam always produces an alcohol. So for this one, the answer should be C. So the alcohol, if we were curious about the structure, would look something like this. So an H, carbon, HOH, carbon, HOH, carbon, H. And this is essentially just a diol because it has two alcohol groups. Moving on to number 36. Which statement about members of the homologous series of alcohols is correct? So let's read option A. Alcohol with two carbon atoms in each molecule is called methanol. That's wrong. It's supposed to be ethanol. B. Butanol can be combusted to give carbon dioxide and water only. Yes, that is correct. When complete combustion occurs, we do get carbon dioxide and water. So B might work. Let's look at C. Ethanol is the only alcohol that can be oxidized to carboxylic acid. That is wrong. All alcohols can be oxidized. D. Propanol can be made by catalyzed addition of steam to ethene. It should be propene because we are looking for propanol. So again, that is wrong. So the answer for 36 is B. Moving on to number 37. The diagram shows the structure of a compound called ethanoic anhydride. 1 mole of ethanoic anhydride reacts with water to form 2 mole of a carboxylic acid only. This carboxylic acid reacts with ethanol to form an ester. How many moles of water react with 1 mole of ethanoic anhydride, and what is the structure of the ester? So if you look at this part, if we separate the two parts like this, we can think of this as one carboxylic acid and this as another carboxylic acid. So essentially what happens is when you add water, hydrolysis occurs. So this bond is broken down. So what we end up getting is one of them takes the oxygen. So the product of the first reaction would be something like this. So the water, which will give H plus and OH minus. So the one that takes the oxygen gets the H, and the other one that lost the oxygen gains the OH. So at the end of the day, both of them form ethanoic acid. So ethanoic acid is produced when water is added, and then this ethanoic acid reacts with ethanol to form an ester. So our ester should be ethyl ethanoate. Basically 2 carbons for the ethyl part and 2 carbons for the ethanoate part. And if you were to draw it, it would look something like this. So this has 2 and this also has 2. So it's between A and C. And how many moles of water do we need to break this down? We already saw that we only need an H plus and OH minus, so only 1 mole of water is required. So for 37, the answer should be A. Moving on to number 38, 4 samples are analyzed using paper chromatography. P, Q, and R are pure substances. M is a mixture of different substances. Which substance does mixture M contain? So to find this, all we really have to do is just mark each spot from M. So M and Q have a spot on the same level. And then M and P also have a spot on the same level. And this spot, the one at the end, doesn't match any other one. So in that case, M contains P, M contains R. So which substance does mixture M contain? P and Q only. So the answer for this one is going to be C. Moving on to number 39. A student is making a sample of aqueous copper to sulfate. The student adds an excess of copper to oxide powder to warm sulfuric acid and stirs the mixture. Which apparatus is used to separate aqueous copper to sulfate from the excess copper to oxide? Aqueous copper to sulfate is a solution. Excess copper to oxide is a solid. So what we want to do is separate a solid and a solution. So for that case, we will always simply use a filter funnel and paper. So the answer for 39 is C. And the last one, number 40, how can a pure sample of barium sulfate be obtained from barium carbonate? Now, barium sulfate and barium carbonate is insoluble. Barium sulfate is also insoluble. So look at the first one. If we try to dissolve barium carbonate, that won't work. So C and D are wrong. We can dissolve it in acid because all carbonates react with acids. So A and B are fine. Add dilute sulfuric acid. Yes, that is also fine. But the last part, crystallize and wash. Now, crystallization works for soluble salts because we get a solution and then we heat that solution and cool it down to form the crystal. But barium sulfate is an insoluble salt, and insoluble salts can just form as precipitate, and they do form as just precipitates, and all we have to do afterwards is just wash that precipitate. So for 40, the answer is simply B, and that is the full paper.